This is a section about the classic algebra word problems, and they're all based on distance equals rate times time. So if you had a speed in miles per hour, you multiplied it by how many hours you went, doesn't that mean how many miles is left over? So this is my speed, some miles per hour. I do that for 5 hours. Well, I know how many miles I've now gone. And so the key to these word problems is that we're going to use this formula, distance equals rate times time. And then most of them, there are some harder exceptions, but most of them, we're then going to try to create a formula based on the distance. So let's get started. Okay, so here's the classic. We got the two trains, and let's see what they're doing. Okay, so they're both going in the same direction. Let's get a picture here. So I've got an express train and the local train. Okay, so this one is 14 miles an hour faster, gets to DC in 4 hours. Local train takes 5. So this is what we need. We are going to fill in this table here, where the distance equals the rate times the time. Now, they're telling me that the two trains, express can do it in 4 and the local can do it in 5. Let me see if they've done all this for us. Yeah, they have. Now, each of them has a speed. Now, I would usually just use x, but so the local, we don't know how fast he goes, but they tell us that the express is 12 faster. So I can build a speed off the local. Do you see what they've done here? So, and again, I would have my dictionary up here. Make sure you know what it is you're looking for. Okay, now what about the distance? Well, the formula here naturally tells us what the distance would be. I can just multiply these together. Did they do that too? Yeah. Just multiply these together, and this column now has got my two distances. So once I have the table filled in, the question is, well, what do they want us to build an equation out of? Well, they told us, implied, that the two trains have gone the same distance. So even though this is math language, this is the distance of the express train, and this is the distance of the local train. It doesn't look like a distance, but it is. It's in math language, that's the two distances. Well, if they've gone the same distance, we can just set them equal to each other because they've traveled the same distance. And now we're just going to clean this up and solve it, and we get r is 48. Now that was the speed of the local train, so if you want the other, go back to your dictionary. So we're going to set, this is distance equals rate times time, but we're going to put the distance on the far end. Now we've got the two people, we've got Wayne and we've got Dennis. Okay, so I'm going to say x is the speed. Let's see, who's faster? Okay, we're going to say this is the speed of Wayne. Okay, now you could put both people over here in the dictionary, but our table's going to do that. So this is Wayne's speed. And I know Dennis, it tells us, is 7 miles an hour faster. Okay, so I've got their two speeds. Now, let's see. It took Wayne 2 hours to ride to the beach. It took Dennis an hour and a half. So we're going to finish our table by just multiplying across. That's what distance equals rate times time is doing. So we've got 2x. I just wrote this so it's algebraic, but I'm just multiplying them together, and I've got 1.5 times that entire rate. Distance equals rate times time. Do you see what I've done there? Okay, now we are going to build an equation out of this column here, this distance column. And what do we know? They both have ridden the same path. So they've gone the same distance. Now, we've got it. The two distances are the same. So let's solve this. We're going to distribute there. Oh, no, that's not going to be. Hold on. I thought I knew what that would be, and I'm wrong. Yeah, 10.5. Okay, that's supposed to be a 10.5 there, sorry. Now, we've cleaned this room up. It's clean. But I have x's in both rooms. We haven't seen this much in these kind of problems, but I've got to get step 2, get him back in the same room, or we're never going to solve this. So I've got 0.5x equals 10.5. Now we're going to divide both sides by 0.5. And that is Wayne's speed. Now we need both speeds, right? Yeah, both speeds. So I know Wayne's speed, and Dennis is 7 miles an hour faster. So he's 7 more. So Wayne was 21 and Dennis is 28. Okay, I really recommend you pause this one. We've got two people, Jeremy and his mother. So we're going to set it up as rate times time equals the distance. Okay, let's see their speeds. So we're going to call his speed x. Oh, hold on. No, it's his mother's that we can build off. Mother's speed is going to be x. Okay, so her speed is x, and we know he is 20 miles an hour faster than her. Okay, he can drive there in 4.5 hours. She can go in 6. Now, we'll figure out an equation in a minute, but first let's fill in our distance column, which is always just the two of them multiplied. Now, have they gone the same distance? They have. They've traveled the same path, so once again we have the two distances. The distance column must be equal to each other. So I'm just distributing here. I get 90. Okay, now the rooms are clean, but we have idle nodes in both rooms. We don't want that. We'll never get them alone like that. So I'm going to get all the x's back together. And finally, get him alone by dividing both sides by 1.5. So x was his mother's speed, so she's going 60 miles an hour, and she's going 20 more than him, so he must be going 80, and he needs to slow down. Okay. All right, so what they're going to change on us is just how these distances are working. But let's get it set up here first. Yeah, let me talk about that in just a second. Oh, are they going to give us our... No, they're not going to do it, so we'll do it. All right, so I'm going to build my table here, and I've got Christopher and his parents. And who's faster? Okay, so we're going to build off the parents' speed. If you read through there, you'll see their speed is the one we can build off. Theirs is idle node. So we got an idle node there, and he's 10 faster. Okay, so now what about times? So Christopher is in the car for an hour and a half, and his parents are in there for an hour. Okay, so let's not worry about the big picture here. We're just going to fill in our distance column, and we've got 1.5 times x plus 10. And then I have 1 times x, but that's just x. Okay, so what's different this time is that I know the entire distance that they've traveled. They started an hour and 115 miles apart. So I need to take this distance, and let's see what we get. This is Christopher's distance, and this down here at the bottom is his parents' distance. So if they've gone a total of 115, do you see that we could add them? So what's different this time, we had been going the same distance, but now we haven't. We know that Christopher traveled this distance, his parents traveled this distance. Now they've changed it to r, but the same thing. And that it was 115 miles is how much they must have covered if they're going to meet each other. So we're just going to solve that now, just the same stuff we've been doing. R is 40. Now, we know Christopher was 10 miles an hour faster. We could use our dictionary or whatever. and we get 50. Okay, so read through this here. Let's see who's... Okay, so I'm going to do Karina's speed. Now I've got Karina and I've got her brother. So rate, time, and distance. Okay, so Karina's is I don't know, and we know her brother was driving 15 miles an hour faster. Now how far did they go? Karina took 3 hours, her brother took 4. Okay, just making sure they're doing the same thing. They are. Okay, so let's fill in this distance column. Remember, this is a parenthesis here. You got to multiply the 4 times that entire rate. Now what they're saying is they were 410 miles apart. They each did some of the driving. So their distances again add up to be 410 miles. So they were driving towards each other again, but they've covered 410. Now they didn't cover it evenly. So this is Karina's distance. This is her brother's. If you add that up, they've covered the whole 410. Now we're going to just solve that. Sorry, 410. Okay, so we clean that up. Now we need to get x by himself, or x alone. Sum of 7x is 350. Okay, so that was Karina's speed, and her brother was going 15 faster, so he's going 65. Okay, pause this if you want to try it. I'm sure we're going to have the same kind of thing here. We got Ashley and her parents, so hold on, I should do who's going slower. Do you notice that all the kids are driving faster than the parents in these stores? Just saying. Okay, Ashley's speed is, or no, sorry, this should be her parents' speed. So we're looking for her parents' speed, and we've got rate, time, and distance. So her parents are I don't know, and Ashley's going 7 faster. Okay, so they both drove 2 hours. So I'm going to put that together and make their distances. All right, now what's happening? They're meeting partial way there. So they're coming at each other again and covering a distance of 234 feet. So we're once again adding those up. They're both covering, these are distances. I know they don't look like it, but in math language, these are distances. And so they each covered some of the distance for a total of 234 miles. So I've got 2x Okay, so I just cleaned that up, got the x's together. Now let's subtract 14 from both sides. Okay, x is 55 miles an hour. That was the parent's speed, and she's going 7 faster, so she'd be going 62. Okay, let's see, what are we doing now? Yeah, this isn't going to change very much. Oh, well, it is the times now. Hold on. Oh yeah, that's all here. Do we have a table? No, they don't. So let's build one. So yeah, what we're missing here is just the time they traveled. They both are traveling the same time. So they're both in the car for the same amount of time. But see, look, let's see what's going to show. All right, so it doesn't matter who's who. Oh, I guess it does technically. So here, this time we have the rates. In the last exercises, we always had I don't know, and we built the other rate off the other one. Not this time. This time we have their entire speed. What's missing is we don't know their time in the car. They're both in the car the same amount of time. Now, we always fill in the distance column, and we're going to use this distance column to make our final equation. Well, here's what we know. They were driving away from each other, and now they're 325 miles apart. So in math language, that's a distance, and math language, that's a distance. If I add those two distances up, it equals 325. I don't know why they left. It equals 325. Okay, so they were doing it right down here. So now we combine like terms. Just divide both sides by 130. They must have been each traveling for 2.5 hours. Okay. So again, it's the time. They're both the same amount of time in the car. So we're doing rate, time, and distance. So Pierre's going 75. Monique's going 68. They're driving away from each other, right? Yeah, they're driving away from each other. One's going north, the other's going south. So we're going to fill in our distance. I should have used x's. I don't like using the t's, but okay, so they were in the car the same amount of time. Well, let's make the distance column. And lastly, at the end of this time, they're 429 miles apart. This is why I don't like t's. They look like the addition. So we're going to combine like terms here. I get 143. Now, all that's left is divide both sides by 143. So the time is 3 hours. Okay, last one here. Are we, yeah, so time is what's missing again. Rate, time, distance. So I don't know how to say that name, but Drem 72, he's going 76. I'm going to make these I don't knows now. Okay, so we know they're going the same amount of time. We always fill in the distance column, which is just those two multiplied together. Now, they're driving apart from each other, and when they're done, they're going to be 330 miles away from each other. Now, divide both sides by 148. Yeah, I don't think anything's wrong. Let me double check this. We got a weird answer. 2.23 hours. Let me double check. 72, 76, and they're 330 miles. Yeah, so they gave us a weird answer there, but so they're each driving for 2.23 hours. Okay, distance equals rate times time. This is very much fun, but you need that chart. You always fill in the rate and time column and then multiply across to create the distance, and then see whatever clever question they've given you in order to see how you match up the distances. Sometimes if they've traveled the same distance, you set them equal to each other. If they're driving apart from each other, you're going to add them up.